Now, next point is the galvanic cell useful in day-to-day life. Now, galvanic cells is very useful in our daily life. You know that we have used in different suppose that the electronic watches, that is battery also. So, more instruments they generally used in that particular galvanic cells. Okay. Now, galvanic cells classified into primary voltaic cell and that secondary voltaic cell. Okay. So, galvanic cells are voltaic cells classified into two types, primary and secondary. Now, very best familiar example of primary voltaic cell, this dry cell. Okay, this is known example, simple dry cell, that is battery cells. So, we know that every day or NICAD, much more different, that is battery cells is available, having that near about that voltage is what 1.4 volt. Okay. Now, in galvanic cell is what generally when galvanic cell is in discharge during current generation, the chemicals are consumed, and once the chemical consumes in primary voltaic cell, once the chemical consumes, then cell reaction stop. Now, if you trying to recharge it, that primary voltaic cells, that cell cannot be recharged. You understand? So, that cells cannot be recharged by reversing the current flow is also. That's why once the chemical used in that particular cell, particular voltaic cells, then that cell reaction will stop and automatically life of that particular the voltaic cell is the stop. Okay, so the way of that such cell is called as primary voltaic cells. Means those cells which cannot be recharged, or the cells means electrolytes cannot be regenerated, or the cells cannot be recharged, that is primary voltaic cells. Now what is secondary voltaic cells? Secondary voltaic cells, known examples, that is lead storage battery. You know that very well known example, that is the lead storage battery, which can lead storage battery is the main point including here, it can act as also electrolytic cell and also the galvanic cells. This is lead storage battery. Okay. Now we will see here secondary voltaic cell is what? Those cells which can be recharged. Such cells called as that secondary voltaic cells. In such cell, exactly what happens? The recharging is possible by reversing the flow of current. Due to the recharging is what here the chemicals that consumes, they are again that reproduced. So electrolytes or that the chemicals that will be the reproduced into that secondary voltaic cells. Regeneration of that electrolyte takes place. That's why recharging is also possible in the secondary voltaic cells. These are the examples. Another also Mercury cells and nickel cadmium cell, that is called as NICAD. In short, that is NICAD. Also, this is the way of that. This is the generally the secondary voltaic cell. Now, this one point lead storage battery. Into this case, when lead storage battery is in discharge, is in operate, that time it is the application. It is act as that particular that the galvanic cell. But when lead storage battery, you can recharge it. During recharging, it can act as that the electrolytic cell. So this is the acting as double acting as like this. The twice part of this, like this is acting here. The lead storage battery. Nickel cadmium or NICAD storage cell. Nickel cadmium cell is short for NICAD storage cell. It is the secondary dry cells. Nickel cadmium secondary cell, it can be recharged. Now in the cell, anode is cadmium metal and cathode is a nickel dioxide, NiO2, or nickel in bracket the for oxidation state, that is also called as nickel oxide. Now in this cell, electrolytic solution is basic. Now, in this particular NICAD cell, how the electrode reaction takes place? Now we will see at cathode and at anode. At anode, this is way of that cadmium metal plus this is twice OH minus hydroxide, this is ions, and then it get combine with each other, convert into cadmium hydroxide using of these two electrons. This is just oxidation half reaction. And at cathode, nickel dioxide combined with this H2O liquid, and then gaining of these two electrons, so convert of that cadmium hydroxide and nickel hydroxide. So both of these product is here in that solid. So this is reduction half reaction. So this is the gain of electron, cathodic reduction, anodic oxidation. These two half reaction combine together, and then you can get overall or net cell reaction. So net cell reaction is this way. So cadmium metal, then nickel dioxide plus water molecule. So you have to get this cadmium hydroxide and that nickel hydroxide which is in solid. So in reaction product is solid. So therefore, what is that? The benefit, the solid product adheres, that is electrodes, and therefore we can regenerate that this is NICAD cell. So it is possible to generate again to recharge, that is NICAD cell. So the way of that, the nickel cadmium cell, the best cell. So its cell potential is the 1.4 volt. Again NICAD cell is having long life as compared to another dry cells, and the generally this NICAD cell is useful in electronic watches, other photographic equipments, and also in that the calculators. A lot of instruments in that NICAD storage is applicable. Now the next point is mercury battery. Mercury battery, it is a secondary dry cells and it can be recharged. Now in mercury battery, which anode and which is cathode? So anode is here zinc amalgamated with mercury. Okay, so zinc is amalgamated with that mercury. This is acting as anode, and cathode is test of mercury and that particular carbon. And in mercury battery, electrolyte is strongly alkaline. And that solution, and that is the strongly alkaline, this is the best of that potassium hydroxide and zinc oxide. Now electrode reactions takes place in this mercury battery the way of that. Add anode, and this is that cathode. Add anode, this is that zinc is in contact with this one. Zinc is amalgamated with that mercury. So twice OH minus aqueous is converted into zinc oxide and water molecule. Loss of these two electrons. This is oxidation, half reaction, this is that anode, and then second one is that mercury oxide plus water, gaining of this two electron and formation of that mercury and that the two hydroxy ion. This is reduction half reaction. Combining these two reaction to half reaction, we are getting net cell reaction. And this net cell reaction, zinc in G, that's mercury oxide is solid and that is zinc oxide and that zinc. So in this case, overall, no changing electrolytes. Okay, so electrolyte remain as is, and this is all is in solid. So the way of that here, that's why properties are no change in electrolyte here. So remaining as this solid as throughout this. Okay, so therefore the constant supply of that particular current. So having here voltage is same potential voltage 1.35 volt, and this is supplying constant voltage, and this is supplying constant that particular current as compared to the another dry cell, and that is the Lachlan cell dry cell compared to like this. So this is way of that. Now what is the again mercury battery generally uses? So here generally used for in that the hearing aids also, and that electric watches, that is also in case, and the pacemakers in that also. So this is the mercury battery. Now we are going to study electrochemical series. This is also called as electromotive series. This is the last point in this topic. Now electrochemical series is defined as how will you explain this? The electrochemical series in which the arrangement of electrodes with their half cell reactions, according to their standard potential, their standard electrode potential. So according to their decreasing standard electrode potentials. You understand? Arrangement of electrodes with their half reactions according to their decreasing standard electrode potential, and this is electrochemical series. So now we'll see its application. Now this is the first application in the relative strength of oxidizing agent, second one is that relative strength of reducing agent, and third one is the spontaneity of redox reaction. Now look here, basically in textbook copy they have given that particular electrochemical series, one table, and that they have given some half reactions, and that half reactions they have considered right side, left hand side. Okay. Now in central middle part they have given that electrodes of hydrogen, that is standard electrode, that hydrogen potential is that the 0.0. This is standard electrode potential of this hydrogen 0.0. Now at the top, if you move across that bottom to top, that positive values increases. What is that value in this column? That's standard reduction potential values. Then if you go top to bottom, that value is the negative. So this is the lithium having negative value, and this is fluorine that is having positive value. Now this is the first application we have to see, relative strength of oxidizing agent. Now what is oxidizing agent is what? Those substances or those species having tendency to gain electron, so that is called as oxidizing agents. Because oxidation and reduction, this process takes place simultaneously. One substance should donate electron and one substance should be gain electron. That donated electron, that another substance should be gain electron. So the way of that. Now larger inert values, this is the conclusion in this from this electrochemical series. If you observe this standard reduction potential value, it's larger inert values. This is the greater is the oxidizing strength. Okay, so see this value here. If you bottom to top move like this value goes on increasing. Now this is the top side element, this is fluorine, is we know that very well known, that is act as strength of that is oxidizing agents. Fluorine is very good oxidizing agents. Its strength is more. Therefore, increasing strength of oxidizing agent is like this, bottom to top. Okay. Left hand sides they have given the way of that oxidizing agents, and right hand side they are given like this particular the reducing agent. Now the second one is that relative strength of reducing agent. Okay, so right hand side species again that reducing species, so the reducing agent. Now here if you observe this again that the series top to bottom you move like this, the negative value goes on increasing. The more negative value, the increasing strength of reducing agent. You know that lithium, sodium, these are the group first element, they are very good reducing agent, can act as a good reducing agents. The strength of such metal is more. So more negative value, greater strength of reducing agent. So that's why this negative value goes on increasing. Now the third one is spontaneity of redox reactions. Okay. Now in galvanic cells, the same potential is positive, then that reactions the spontaneous. Okay. Now for spontaneity of redox reaction, this is from electrochemical series is what? Only if species with higher inert value is reduced, and that with lower inert values, standard reduction potential value is oxidized. Okay. So this is it. Means what here? Those substances having suppose the upper side of this the positive value, and though here the next substance is the below its side. So such substance can here that particular the way of that oxidize to the other elements. This is way of that.